In question number 23, we're asked to draw the graph of this function y equals 4 sine x minus 3 cos x. And when I graph that, it does look like a sine function here. So look, this is what it looks like here in red. And our sine, it looks like a sine function. And it asks us to then use this, try to find the transformed function. Basically, it's a vertical expansion and a shift to give us the same function. Okay, so we're going to equate this function to a transformed sine function. Now, first of all, we have to just double check to make sure that the period is 360 degrees, although, you know, I like to do it in radians, but this is done in degrees. If we look at this, the equation, we can see that it's just going to be repetitions. Both sine and cos repeat the same as each other. So once we hit 360 degrees, it will repeat. And we can actually see that as well. If we take a look at any points, we can see that any points are going to be 360 degrees apart. So for example, this point here and this point here will represent one full period here. Okay, so that is, there is no horizontal compression or expansion, which is indicated that there's no coefficient on the x. So really all we need to do then is to figure out where the horizontal shift is. So we just need to locate that blue dot there. It's at 36.87 degrees, and we can get that straight from the calculator. And then the A represents our amplitude. So we just need to figure out the amplitude and horizontal shift. The amplitude, we can just do it visually. Its amplitude is 5. So then the equation that's going to be equal to that this expression 4 sine x minus 3 cos x is going to be 5 sine, so my amplitude is 5, x minus 36.87 degrees. And again, we're doing this in degrees, but really we should be doing most things in radians. Okay, so this transform function is an equivalent expression to this function that was drawn here in red.